Let's go ahead and get started. So, if no one has taken the opportunity to do this yet, I want to welcome you to the physics community. Or, as Haggard would say, you're a physicist, Harry. And I don't mean that jokingly, right? You are all taking physics classes, which means you are members of the physics community. All of us, with me and Tyler Ewing, we're all part of this physics community. And that isn't, that's not a joke, right? It doesn't mean that you're finished learning all these things that you're going to learn. Heck, I'm still learning a lot of things. You are still learning a lot of things, right? That's just the way it is. You're always learning. It doesn't mean that you're not part of this community. And so one of the main things, or the main kind of core of this course, is that Physics 281 is going to be all about being a practitioner of physics and a member of the physics community. So what we are doing in this course is all going to be about bringing you up to this, welcoming you into this community, and also helping you gain the knowledge and insights so that you can be a better member of the community, a better practitioner of physics. So what does this mean to be part of this club? Well, in general, right, a community has shared sets of knowledge, skills, and passions. So if we're going back to our wizarding world example over here, right? All the wizards, they have to know certain things. They take their history of magic classes and they read the newspaper and learn about, the happenings. And what's the name of that newspaper? The Daily Prophet. Okay, yeah, Daily Prophet. So I forgot, it's been way too long. They read about these things, they know about what's important. They have skills, right? They have to go and learn that it's Wingardium Leviosa, not Leviosa. And there's things that they care about, right? Like maybe saving the world from Voldemort. So just as a community has these three aspects, the physics community does too. And so what's probably, what we want to ask, right, is, okay, what do physicists know? What do they care? What do they do? And what do they care about? So let's start about what they know. And I think this one's pretty obvious, right? Physicists know a lot of, formulas and laws and equations. These are the things that you've already been learning about in your introductory courses. And that's great. There's still more to learn, I'm sure you know, but this is something that's well on your way. And we're actually going to spend less time on that part of stuff in this course. In this course, we're also going to, in general, physicists know about, the big scientific issues that are affecting them, right? So, for example, when Yue writes a grant, he's probably not just, writing a grant about something random. He's probably finding an issue that matters and trying to solve it some way, proposing a way that he could solve it. And so what he does, right, is he probably reads a lot of the literature and figures out, what's important in the world, right? So, like I said, this training is well underway. It's going to be less an issue in this class. So what do physicists do? What are the skills that we sort of share as a community? Well, we are practitioners of the scientific method, okay? That means we actually carry out experiments. We develop and test and analyze these experiments and theories. This doesn't necessarily mean that they're all experimental, right? We could develop, test, and analyze theories theoretically, computational, et cetera. We are experimenters, and again, I should probably put that in quotes, right? We develop, whether it's apparatus or simulations or new sets of formula that you can use and play around with them and figure out how to arrange them so that you get something that is interesting to analyze. And then we collaborate with others. Collaboration is an extremely important part of what it means to be a member of a physics community, right? This course is going to be heavily focused on collaboration, and that mimics what it's like in the real world. There's very little science these days that can be done all by yourself. And so we're not going to do science by ourselves, right? That's just not how it works. And so being able to work with others is the way that we move the field forward. And finally, communication. Basically, being able to communicate is also inexorably linked to being a member of the physics community, right? Because you need to be able to, say, communicate with peers, maybe in papers, journal articles, right? You need to be able to communicate with experts, say your boss or somebody who is in a position to give you a grant. You need to be able to communicate with the general audience, maybe members of the government to do advocacy work, the students to teach them. And this all can need to happen in oral and written format. So these are some of the things that physicists actually do on a daily basis. And you're looking at this and saying, okay, well, I kind of knew that already, right? But here's the thing that's a little bit more confusing. What do physicists care about? And the thing here, right, is that I think a lot of students tend to think of physicists as being people who really care a lot about solving equations. Like maybe we go home after the workday and like, oh boy, now I get to solve some equations. But actually, right, of course, that's not, there maybe some people like that do exist, right? But despite the fact that perhaps physicists are a little bit more nerdy than the audience in general, physicists care about a lot of things. And what these things that physicists care about are shape what they do in their daily lives as scientists and beyond. So this means that we should think about what it is that physicists care about, because as good members of this community, we should be able to think and speak intelligently about the things that matter to each other in our community, right? But then there's the question, what is it that physicists care about? Really, like I haven't answered that yet, right? And I'm not really in a position to tell you, I'm just one physicist, right? So what we're gonna do is a little activity. What I've done is I've assigned each of you a single copy of a publication called APS News. So the APS, or the American Physical Society, is a professional organization. It has over 50,000 members in the US and beyond, right? And it's like a huge professional organization for physicists. And APS News, it is a publication that is by physicists and for physicists. Thank you. So I imagine that if we find something in APS News that has made it through the editorial board, this must be something that physicists care about. So each of you is going to get one back issue. It's just going to be a PDF on Sakai. You are going to scan through, and you're going to just look at the headings, the titles, right? And headlines, there's the word. And you are going to pick out one that is not about that sort of technical aspects, not about physics knowledge and skills, something about something that people care about, okay? Or that the author cares about. And you're going to pick one of these, and you are going to maybe briefly read it. I'll give you just like 5 minutes, no more time than that here. And then we're going to come back and share the things that you saw, okay? So I am going to put it here, go to resources, lectures, and lecture 1 on Sakai here. Here are your assigned articles. So that's just the number of the PDF. What I'm going to have us do now is, so I have a prediction, no changing now, okay? I have a prediction that the articles you chose probably can fit into one of these categories. So what I'm going to do is we're going to go around. We'll start on this side, work back, and then work forward. Oh, and Zoom people then. And say the name of your article. Say your name, say the name of the article, and then if you can, try and pick out one or more categories that this article might fit under. So we've got like government policy, diversity, equity, inclusion in education, modernizing education, taking a stand, history of physics, outreach, celebrating accomplishments, and access to physics and knowledge. Okay. So let's start with excellent. So there we go. I think we've arrived on an idea that these are some of the things that physicists care about. Okay, I think that that's what this tells us. So what we're going to be doing in this course is relevant to both these skills and passions, and to some degree the knowledge parts of this chart. And so what I'm going to do now is I'm going to walk you through the 5 course goals in this course, and we will see why each of these categories fits into the goals, okay? Thank you for doing that. I appreciate all of your interesting articles. I wish I had time to read them. So the first course goal, I think, is kind of the one that you would expect to be a course goal when you're coming into an experimental techniques course. It's about the tools and techniques. We're going to make a window and look into, the world of what it is that physicists do, and in the lab on a daily basis, like experimental physicists, and give you a chance to actually twiddle those knobs and push the buttons. So these are the things like the calipers and the oscilloscope, and you'll see this is a Michelson interferometer, which we will be using multiple times in the future. This one in particular is the one that is at the core of the LIGO, Laser Interferometer Gravitational Wave Observatory. But we have one in the classroom too. It's just a little smaller and less good, but still works. We're also going to be using some non-physical tool, or actual in the classroom tools, right? We're going to be using things like MATLAB and other software to see what it is that physicists actually spend their day doing. And so this goal is all about knowledge and skills, right? These are you have to know things about what each instrument does and know how to use it. Goal 2 is about the scientific process. So as physicists, we need to know how to form a hypothesis, design an experiment to test that hypothesis, figure out which data to take. That's a surprisingly challenging part sometimes. Sometimes you know exactly what you want to test, but how to actually take data, that can be hard. And that's a question that you're going to have to grapple with multiple times here. Then you're going to figure out how to analyze the data that you get and form conclusions, for example, with hypothesis testing. These two things are two representations of the exact same data taken from a paper of mine. And as you can see, they look different. I won't tell you what they are right now, but they look different and they tell different stories, even though they are the same data. These, of course, deal with knowledge and skills again. You have to know what the techniques that you can use are and have the background skills to implement them. How do you actually run a hypothesis test, that kind of thing. Number 3 is all about communication. Like I said, scientists need to be able to communicate and defend their work. We have to be able to make persuasive arguments for what we're saying. We can't just state the facts as much as help people understand why they should care. Why they should care is really important, actually. So we need to be able to both communicate in written and oral format. So we're going to be doing a lot of writing, for example, lab reports written in LaTeX typesetting language, and verbal like chalk talks and final project, and also more informally, just explaining things to your group members, right? These have to do with skills and passions, right? So skills, you need to practice communicating. It's something that's really hard. Oh boy, was I nervous the first time I stepped into one of these rooms to give a lecture, right? You guys are all scared looking at me, but it gets easier with time. And you also, this is definitely something that physicists care a lot about, right? Like, speaking from personal experience, I really like teaching, and this is something I'm working hard to get better on, not just because, there's like some set end goals, but because this is something I am passionate about. And that doesn't necessarily mean that the only kind of things that physicists care about would be the teaching side of things, right? Maybe they're passionate about, communicating with the public or with government representatives, et cetera. Goal number 4 is going to be about diversity, equity, and inclusion. Basically, we are going to make sure that as members of this physics community, we know how to speak intelligently with other members about some of the issues they care about. This, importantly, does not mean you have to agree with other members of the community. In fact, what a freaking boring world it would be, or a boring community, if we all agreed on everything, right? We are just going to be doing some readings, and then you will be responding in reflection essays to these readings based on some of the issues that you see up here on the board. These have been chosen not by me, but by a panel that looked at some of these issues from APS News and decided on topics that made sense based on what physicists care about. So you're going to be writing some short, like 500-word reflection essays maybe think of them as one click above a stream of consciousness. You could also record them, audio or video if you really want, and turn those in. There'll be 6 of these throughout the term. And that's going to be a way that we can kind of engage with some of these issues that are important to other physicists in the world. We're not going to, what I'm trying to say is, I don't want you to write what you think I want you to write. I want you to write what you think. And I'm legitimately interested. I'm very interested to what you have to say, at least. The first one's assigned, and it will be due next Tuesday for the Tuesday section, and Wednesday for the Wednesday section. This, of course, is all about the passions part of the table. And finally, we've got group work. We need to be able to work together. I already talked about how important that is. And I have to do it on a daily basis. This is my advisor and a group member and me. And so as groups, you should expect to spend some significant time working with your group to figure out how to work with your group. That's the intention of this class, that it will be hard at first, but you will learn to rely on your group members because you have to. The work in this class is too hard for you to just go it alone, right? You need to rely on each other. So, take some time to think about, how are you going to communicate? What app are you going to use? How quickly do we expect each other to respond, for example? Just simple things like that. How are you going to manage your time? What about safety? You should talk, with each other, make sure that you're not doing something that's making someone else uncomfortable. How are you going to deal with problems that arise? It's important to have these discussions, but the good news is that you get something in return, right? Many studies have shown that you all can help each other learn much better than I could ever cram information into your brain. So by being a good member of a group, you can expect to learn the physics better than if you were just listening to me blabber on from the front of the classroom, he says, as he blabbers on from the front of the classroom. All right, so those are the 5 course goals. And I think you've all already watched the syllabus lecture thing. So hopefully you can go back now and look at every assignment. You should be able to see that every assignment in this course gets at 1 or more of these 5 course goals. Okay? If there's ever an assignment in the course that you find that does not help achieve one of these 5 course goals, you should let me know, because I've messed up, right? Cool.